Hello dear students, in this lecture we are going to see the introduction of push down automata. In short, it is called as PDA. So basically what exactly the push down automata is and why it is powerful than finite automata. A finite automata cannot accept the language L, that is string of the form a raised to n b raised to n, as it has to remember the number of a's in a string, and so it will require an infinite number of states. So as finite automata does not have any type of memory, it cannot remember anything. So this difficulty can be avoided by adding an auxiliary memory in the form of stack. So each and every PDA system contains one stack. While removing the elements, we follow last in first out basis because stack works on LIFO basis. That is, the most recently added element is removed first. For example, as shown in the diagram, if we have the string a raised to n b raised to n, that is, the number of a's are equal to number of b's. For example, we have 2 a's and 2 b's. And if we want to implement or design or construct the push down automata, we can design like this. Whenever A encounters or whenever we read A, we push one A into the stack. And whenever B encounters, we pop one A from the top of the stack. So let us see 2 times A and 2 times B. So when first A comes, we enter it into the stack. Another A comes, we again enter into the stack. Now after 2 A's, we have B. Now whenever B encounters, we pop first A. So we popped it from the top of the stack. Another B is also coming, so we are popping the lowest A from the stack, and we get empty stack at the end of the string. So when we get the stage as empty stack after ending the string, then that PDA or that language is accepted by PDA, we can say. So thus the matching number of A's and number of B's is accomplished, and this type of arrangement where a finite automata has a stack leads to a generation of push down automata. Now every push down automata has some components like input tape in which all the input symbols are placed. Then we have finite control, one stack is there, and based on the finite control and the stack position, we can say that whether a given language is accepted or rejected. Now PDA has different components that we have seen in the diagram. So what is input tape? Input tape is divided into many cells or symbols, and it has one head which is called as input head, which is used to which is read only and may only move from left to right direction, one symbol at a time. Finite control is another component. The finite control has some pointer which points the current symbol which is to be read. And stack is a structure in which we can push and remove the items from one end only. The stack size is infinite. In pushdown automata, the stack is used to store the atoms temporarily. Now this is the formal definition of pushdown automata. Pushdown automata basically is a 7-tuple automata. In those 7 tuples, capital Q denotes the number of states. Sigma denotes the input symbols. There is one special symbol which is used to show the push down symbol. Then small q0 is the initial state, and one special symbol is z0 or any special symbol you can use here to indicate the initial symbol on the push down store. And last is the final state, which is in the finite automata, which is indicated by capital F, and 7-tuple is the transition function delta from Q into or Q maps to sigma, null and the push down symbol. So in general, symbolically, PDA is a 7 tuple, namely Q, capital Q, sigma, spatial push down symbol, then delta, Q0, Z0 and F. So this is all about push down automata, or this is all about the introduction of push down automata.